So what you need to know about the derivative is essentially it can be the average rate of change. So it says here for any function y equals f of x, the average rate of change is the change in y values here divided by the change in x values. So again, if you have 2 points, points A and B, obviously the x value is denoted as the A and B here, and the y values are denoted as f of A and f of B. Okay, so again, this functionality here, or this formula, is just the change in y divided by the change in x values. Should be no surprises there. The average rate of change. Definitely when you're looking at these questions, if they are asking for the average rate of change, this is what you're using. Please note that there is a difference between the average rate of change and the instantaneous rate of change, which we'll be looking at a little bit later. So average rate of change is just this. So here is an example, worked example number 1. I'm showing how this happens. So it says find the average rate of change with the function, it's listed here, as x changes from 1 to 5. So again, what we need to do is find out the change in y divided by the change in x. So what we're going to do, we're going to find out the values of f of 1. So substituting in 1 into the equation, we get 4. So this is obviously going to be the y value when x is 1. And we need to find out what's going on when x is 5. Substituting it in, its y value is 20. Doing the average rate of change, the difference between the y values, 20 take away the 4 on the top line, and divided by the change in the x values, the 5 take away the 1, and we get the answer as being 4. Perfect. I think you guys should be fairly happy doing that. Again, a reminder about the tangent of a curve at a point. So some things that you need to be aware of with the terminology. It says we first recall that a chord of a curve is a line segment joining P and Q on the curve. So here we've got lots of chords joining those together. It says a secant is a line through points P and Q on the curve. So again, we've got a secant here. It says the instantaneous rate of change at P, so at this particular point, can be defined by considering what happens when we look at the sequence of secants between P and Q1, P and Q2, and so forth and so forth. And the whole idea is looking at the instantaneous rate of change as this second point, Qi, gets closer and closer to the point P. Again, it says here we will focus our attention on the gradient of the tangent at point P. Essentially what happens is once that point Q gets so close to point P, it's essentially just the tangent at that point. Alrighty, there's more information that goes into this here, which illustrates that you guys have looked at this stuff before. You should be fairly happy with this stuff. So essentially what it's saying is as we make these secants really small, this h value is going to get really small and get as close to being as 0. When that happens, ultimately we're going to be working out the derivative. Now, in order to make that h value as small as 0, or basically 0, we're going to use limit notation. So again, the notation for the limit of 2x plus h, as h approaches 0, gets really close to 0, or gets to 0, is written as follows. So limit as h approaches 0 of 2x plus h. That's how we write it. It says the derivative of a function with the rule f of x may be found using each of these things as discussed. Let's have a look at it in a worked example. It says here, consider the function. We've got f of x equals x cubed. By first finding the gradient of the secant through the point P 2, 8, and we've got the point Q here. It says find the gradient of the tangent to the curve at that point P. Yep. So again, what you need to know is to find the gradient, first of all, of PQ. It is the difference in, or the change in y values So we've got the change here between 2 plus h cubed and 8. So taking those away, the change divided by the change in the x value, so 2 plus h take away 2. We're expanding out and simplifying things down, grouping like terms and so forth. We get to this here. Now some people are not really sure where to go from here. What you need to do and remember is that is to factorize the top line here. So h is a common factor to each of these, so h can pop out the front, and then on the top line you're left with 12 plus 6h plus h squared. And because you got the h out the front as a factor and you got the h on the bottom line, they cancel out and you are left just there with that. Okay, so writing it out in full, you'd say the gradient of the tangent at line 2, 8 is the limit as h approaches 0, 12 plus 6h plus h squared is equal to 12. Because essentially what happens is, yeah, as it approaches 0, if you put a 0 in there, put a 0 in here, there's nothing, you're just left with the 12. Alrighty, let's have a look at following practical examples determining limits. So it says here, find the limit as h approaches 0 for the following. Again, it's a matter of substituting in where h is 0. This here will become 0. 20x times 0 is 0. Plus 0, that's 0. They're all gone. They're cancelled out. You're left just with the 22x squared. Cool. This one here, let's evaluate the limit as h approaches 0 for this here. Now, some people just go running into this, and I saw this in year 11. People go, okay, I'm going to substitute in 0 here. When you go to divide by 0, all problems start to exist. Yep, everyone starts going, okay, I'm not sure what's going on. Trick with these is you need to make sure you factorize the top line, pulling out h as a common factor out the front. Once h is a common factor out the front, on the top line you'll be left with 3x squared plus 2h. With those h's, the h as a factor out the front and the h on the bottom line will cancel out. Once you've done the cancelling out, as we said, you'll just be left with 3x squared plus 2h. Substituting 0 in there, the 2h part will be disappear. It's 0, and you'll just be left with 3x squared, which is this here. Okay. Good news is, if you need to find the limit as h approaches 0 for 12x, obviously there's no h in there, so the limit is just going to be 12x. Last but not least, it says find the limit as h approaches 0 for 4. Again, there's no h here. Limit as h approaches 0 of 4 is just going to be equal to 4. Good news is you can do these things with your CAS calculator. I'd encourage you to have a go at actually trying to evaluate a limit. It says here use the h from the variable keyboard, so you know how to pull that up on your screen. Pop that in. There is a limit button in Maths 2, filling out the template, and it will be able to evaluate that for you, which is useful. Again, there is more information on the definition of the derivative. Happy for you to read that, but essentially I know that in year 11 you guys should have looked at derivatives based on first principles. It's this rule here. It says the derivative of a function f is denoted by f dashed and is defined by the following. So the derivative is equal to the limit as h approaches 0 for the following. Okay, so you might recall where you had to rewrite the function out where x was replacing with x plus h, and then taking away the original function, dividing it by h. Okay, they will ask you questions based on first principles. Yep, so it's definitely something you do need to have an understanding of. Alrighty. Let's have a look at the differentiation by first principles example. It says here, determine the derivative of a function by evaluating the limit is called differentiation by first principles. Alrighty, here it says use first principles to solve each of the following. We've got f of x equals 3x squared plus 2x plus 2. Okay, what they've done, first of all, is they've written it out. The formula for first principles. They are going to rewrite out this function, but where x is, we're going to replace it with x plus h. So you can see here, they've replaced it with x plus h, and it's obviously plus 2. That's the first part done here. Next, we're going to go write in the subtraction sign, and then we're going to write out the original function, which we've done here. That is all divided by h. Tick. Hopefully people are fairly happy doing that. From here, it's a matter of expanding things out. Yes, there's a fair amount of work. You do need to be careful that you do not make mistakes with this. All written out. Once it's all been expanded out, and notice here, with the negative, or take away the original function, it has to be multiplied out. So negative 1 times that becomes negative 3x squared, negative 1 times that, etc., etc. So please be aware of that. From here, it's a matter of cancelling out and grouping like terms. Okay, so often there's lots of things that cancel out. You've got 3x squared here, take away 3x squared, bang, they're gone. You've got 2x here, you've got take away 2x here, they cancel each other out. You've got 2 here, you've got negative 2 here, they cancel each other out. Ultimately, you'll be left with 6xh plus 3h squared plus 2h over h. As we were discussing beforehand, to evaluate the limit as h approaches 0, you need to take out h as a common factor on the top line here. So doing that, h comes out the front, you'll be left with the 6x plus 3h plus 2. The h's cancel out, you're just left with that there. From here, you can go ahead and actually evaluate the limit. So as h approaches 0, in this particular case, we're going to substitute in 0 here where h is. You're left with 6x plus 2 as our solution there. Now I know people will jump up and down every year and say, Mr. Failing, why are you making us do this by first principles? We learnt all the tricks last year in year 11 to be able to do the simplification there. Yeah, it's a lot easier to use the other differentiation tools that you do know rather than first principles to get to 6x squared. 6x plus 2. But if they ask you to show this working out for first principles, or hey, in an exam asking you to use first principles and what's going on here, and they ask you to explain something, you need to have an understanding of it. So please don't just fob it off and go, I'm not really concerned. You do need to be concerned about this. Worked example B, again, is asking you to do the same thing. I reckon you guys should be fairly right doing that. Again, just using the first principles, replacing x with x plus h, and then subtracting the original equation, expanding things out, grouping like terms. Make sure you take out h as a common factor and simplify things down from there. There is another way in which you can use a class-paid calculator to do this. They're suggesting you could define an expression. So from that's part B, you could define f of x as being 2 take away x cubed, and you can just type in the following limit in the function sort of notation here to get it happening that way as well, which is useful.